This conference will now be recorded.
All right, so let's see what's object-oriented program. Object-oriented program allows, abbreviation is OOP or OOPS. Okay, OOPS allows us to represent any entity in the form of an object or data structure. All real-world examples such as person, profession, organization are made up of properties and attributes and perform some behaviors. Okay, these real-world examples can be represented in the term of objects. Okay, so before we deep dive into that, you need to understand that this particular programming language is what we call as a high-level programming language. Okay, so something like this. Your programming language sits here. Okay, a low-level programming language is more like a machine-level language. Okay, if you closely work with the machines, the hardwares, right, we call them as machine level language or low level language. But if your program is running on the top layer, application layer, we call it as a high level programming language. So thankfully you guys don't have to deal with this complex memory, CPU, any hardware related data. Okay, you don't have to deal with ones and zeros and anything. Okay, your life is much more simpler compared to a low-level programming language. Okay, so this is where you'll find all the programming languages like Java, .NET, JavaScript, Scala, Ruby. Okay, all these programming languages are high-level languages. Okay, you don't have to deal with a hardware-level programming. Okay. Now, there are several different programming styles. Okay, what I mean by that is if you want to write a software, you can take different approach. Okay, now typically you begin with some problem statement. Okay, you need to write a software that allows people to transfer money. Okay, that's the problem statement. I want to write a software for a restaurant application. That's the problem statement. Okay, now how you take your approach to solve this problem depends on what programming style you choose. Okay, now the most popular ones are object-oriented programming language and procedural language or functional programming language. Okay, now the main difference between object-oriented versus procedural is in procedural you look at the problem statement on what needs to be done, what's the problem, and you keep at it until you find the solution for it. You keep writing the code, you keep writing the program, you keep writing the source code to solve that problem statement. Okay, that's the approach you take. In object-oriented programming language, the approach you take is quite different. Okay, it is more relatable to the real world. Okay, you can actually relate them to what goes on, what happens in the real world. Okay, so in my opinion, object-oriented program is the closest you can get to a real world. It is the best computer simulation of the real world problems, real world examples. Okay, the closest. Okay, so let's take an example, right? The same thing like the restaurant. Okay, so if you have to write a program for a restaurant application, right? In a procedural, you are mainly focused on the problems. Okay, what are the problems you are trying to solve with a restaurant application? What are the things you do in a restaurant, right? You order food, you cook, you pay, and you eat. Okay, you can't simulate eating, of course, but you can simulate how to order food, how it is cooked, how to pay it. Okay, Now, this is the problem statement you're trying to solve. Okay, so remember this. Every time you guys think about a software, you're always trying to solve a real world problem, isn't it? Take the banking application. Okay, before all the technological advances, right? Anytime you have to deposit money, you have to withdraw money. Okay, you have to open an account. You have to physically be there in the bank and process your application. Today, do you have to do any of those things? Can you do that on using any of the softwares like your website or your phone application, phone iOS, Android apps? Can you do that?
Yes.
Yes.
So isn't it the exact simulation of what you did in past in the real world? You can still transfer money from your account to someone else's account. It's just a digital or a computer simulation of what you used to do in the past. Okay, take shopping. You don't have to be physically be there to buy groceries or buy any electronic items, anything. Okay, the same thing we are now simulating with all the retail shopping websites, Amazon, eBay, and all the activities you see there. Okay, all the things that you see there, isn't that an exact replica or a simulation of how you do? If you're in a Walmart, you'd physically carry a cart, move around, look for what you need, and start gathering your things. Okay, and when you're on a website, on a Walmart or Amazon, don't you do the same thing? You browse for everything. If you like something, you say add to cart, or you say remove from cart. You increase your quantity, decrease your quantity. When you're done in the physical store, you literally walk out of the cashier counter, you calculate how much you owe, you pay it, and then you walk out. The same thing is now simulated on the software. Okay, you do the same thing. When you're done, you say checkout. It will ask you payment information, your personal information, and you're done. Software is just a simulation of what you did physically in the real world. And that's why object-oriented programming is so tempting for developers, because that gives you the sense of that real world experience. Okay, now let's look at this. Procedural is very much focused on the problem statement. You don't relate to anything. You just say, I have these problems I want to solve. Okay, I want to simulate. So if I want to simulate a restaurant application, typically what you do is you choose what you need, okay, whatever food items you need, and then you pay. You give your shipping address and everything, and the food will be delivered at your home. Okay, so we are just simulating that rather than walking to the restaurant and doing all that physically. Okay, in procedural, we just focus on the problem statement. We need to solve how people order food. We need to solve how people cook. Okay, so if you want to order pizza, you can actually customize how you want to cook your pizza, don't you? You select what toppings you need. Okay, what kind of thickness, how much cheese. You basically customize everything. So you're actually simulating how you want it to be cooked as well. Okay, now this is a procedural approach. In object-oriented programming, we take a much different approach. And you can decide for yourself which is more relatable in the real world. In the object-oriented programming, we don't just try to focus on the problem. We try to focus on the data. Okay, what are you really dealing with? That's the main question. Now, in a restaurant, who are the main actors? Okay, now don't think about programming. Okay, think generally. When you think about restaurant, what comes to your mind?
A cook.
Very
A
good.
person who cooks.
We have a chef.
A cashier.
Server.
Waiters.
customer, waiter, and food. Okay, these are the actors, these are the players. Okay, these are the things. Okay, these are the objects you think about when you think about a restaurant app. Now let's start assigning things. What does a chef do?
Prepare food.
Makes
Cook
menu.
What does a
Takes food.
cashier do?
Collects money.
Deal with the cash.
Collect or process order, right? What does the customer do?
Eat
Collect
and pay.
food.
They order food, and of course they pay. And what does the waiter do?
They take food to the customer.
Okay. Serve. And food, finally, whatever ingredients and things like that you have. Now this is the approach we take in the object-oriented programming language. Okay, we don't really focus on the problem or the logic. Okay, we don't strive to look at how do I solve this ordering food process or cook. Rather than that, we take a much different approach where we declare objects. What are the objects or the roles or the actors involved in the process of a restaurant app? We have chef, we have cashier, and every person has a unique responsibility. We assign roles and then we see what they need to do, what is their job. Now in both the approach, which one is more relatable to the real world? Which you can just see the names and you can realize what's happening. Which one is more precise, more clear, more relatable?
Object-oriented.
Object-oriented.
Right? So that's the benefit of object-oriented. The reason, I told you, this is the best thing or the closest thing you can ever think of when it comes to software programming. If I just randomly say you order food, it still does the job. Okay, you can still create a decent application with procedural programming, but it is not that close enough. Okay, it is not that easy to manage. But here, this one is very easy to manage, easy to understand, easy to process. So the approach you take to solving the problem of restaurant application, you have many options. Okay, object-oriented programming just happens to be one of them. Okay, now, so you get the idea, right? What is see, everything is an object. You have to remember this. In Java, in object-oriented programming, your focus should be on an object. An object can be a person, or it could be some kind of an activity. Okay, like shopping is an activity. That's an object. Okay, product, food, customer, everything we deal with is an object. Okay, you have to always think about everything as an object. Okay, rather than focusing on the task, you focus on the object and everything automatically falls in its own place. We still cover order food, we still cover pay, we still cover the cook functionality, but now we realize there are a lot many other factors that you need to consider. How do they pay? How is it served? So this is more precise. This is a very abstract overview. Okay, it doesn't give you the full picture of what a restaurant application looks like. Who has the job of order food? Who has the job of cook? It doesn't give you the full picture, but you can still create a decent application using procedural programming. Okay, but this is just so relatable to the real world. Okay, that's what it means when I say it's a real world representation. Okay, so you get the idea, right? What are programming languages and what is the purpose of writing a software? Okay, the purpose of writing software is to simulate your real world problems. Okay, to find a solution for real world problems. Okay, and object-oriented programming is just one style of programming language. There are several. Okay, this is just one approach to solve a problem. Okay. Now, Java is an object-oriented programming language. Okay. It is just one of the object-oriented programming language. There are several other languages that adapt to this style of programming. This is just an approach you take to solve a problem, object-oriented approach. Okay. Java belongs to this category as well. There are other programming languages that also follow the same style of programming. Okay. Java is one of them. Scala, JavaScript, Ruby, C++. There are several programming languages that took the same approach of solving a software problem. Okay, Java is just one of them. Okay, so you can have Java, Ruby, C++, Scala, even JavaScript. Okay, these are different programming languages, okay, that follow this style of approach. Now, let's look at what a class and an object is. Okay, class is a blueprint used to define state or attributes and behavior of an entity. Objects are the runtime instance of a class. Object contains state and behavior. Now look at the highlighted words, class and object. Class defines state and behavior. Object contains state and behavior. Okay, so let's look at this with a real example. Now when you think of blueprint, what comes to your mind?
Means backend, like
Here, the term blueprint generally, forget about
Map.
back and front end.
It's a picture, a drawing,
Map.
A sketch
sketch.
or a plan, isn't it?
Yeah.
If you have a home, if you want to build a home, there is a sketch, okay, which tells you where will be your kitchen, how big will be your bedroom, okay, where will you park your cars. So that's the blueprint on a piece of paper, right? Now that's what the class is. Object, if the blueprint is class, you know, your house layout, okay, that sketch, if that is a blueprint, the object would be the actual house, the physical house that is built. So there is a plan or a blueprint or a sketch which is class, and the object would be the actual building itself, which is built based on your blueprint. Class and object. This is a blueprint versus this is an actual instance of the blueprint. Okay, so whenever you guys write a program, you basically write classes and create objects out of it. Okay, so let me give you an example now. So this is a blueprint for person. Every person should have a name, age, address. This is a blueprint. So am I being too generic or am I being too specific here?
It's generic.
Go for generic.
It's very generic, right? So how about this?
It's specific.
It's too specific. So this is a blueprint. Okay, I wrote a program that says every person should have, I define or I declare that every person should have a name, age, and address. And here we have a name, age, and address, an actual name, actual age, and actual address. If this is a class, then this would be
Object.
an object. Okay, so this is a blueprint of a person. What should a person have? And this is an actual object of the person. Okay, this is an object called John. And this object is of what type or what blueprint? What blueprint does it belong to?
Persons?
Yes. Person. Okay, so here you'd say something like this. John is a type of person. John is based on or created based on this blueprint person. So objects are created out of classes. Okay, class is just a blueprint and objects are created from this blueprint, just like your house. Okay, if you find a new housing community, most of the condos side by side, they look all the same, right? They all have the same standard layout. Okay, so if I give you a blueprint of one condo, can you create 10 physical buildings out of that blueprint?
Yes.
If I give you a blueprint of a Ford Mustang car, and you actually manufacture 1 million Ford Mustang car,
Yes.
Yeah.
then what is the class and what is the object here?
Class is
Blueprint is the
vehicle.
class.
The blueprint of the Mustang car is the class, and those million manufactured actual cars, they are the objects. Objects. Mustang blueprint. Okay, that's how you need to think about it, and this makes your life much easier. Think about this for a moment. Facebook is, of course, a software, right? It is a programming. It's a program. Amazon is also a program, right? Now, Facebook has like over 2 billion customers. Amazon has like over 10 million products that they sell. Now, if I have to write a software for Facebook, do I need to write 2 billion programs?
No, only one.
No. Yes, all you need is one program. And how many objects do you need?
2 billion objects.
Yes, very good. How about Amazon software? How many programs do I need to write to manage my products?
One.
One product. And how many objects I need out of that product?
10 million.
10 million.
10 million. Okay, that's how you need to think about this. So anytime you are about to write a program, always think in terms of generic, abstract way. Do not be more specific. The specific, you will get the more specific nature in terms of object, but your approach to write a program should always be more generic. So a better practice would be person is a common noun, right? What is John?
It's an object.
It's a pronoun. If this is a common noun, this is a pronoun. Okay, so tell me one thing. If I ask you to write a grocery application, okay, where you sell fruits and vegetables, what are the classes you'll create? Okay, I sell bananas, mangoes, and onion and potatoes. I sell these 4 items. Okay, what would be your classes for a grocery application?
Vegetable and
Vegetables.
Fruits and vegetables.
Very good. Fruit and vegetables would be your class. And what will happen to
Onion, potato, mango, bananas.
what are these?
These are the
Objects.
They are the objects of your class vegetable and class fruits. Okay, so you get the idea, right?
yes.
right? So that's class and that's object. All right, so let's go through all the important features. These are like the foundation pillars for the object-oriented programming language. Okay, this is the foundation. These are the main principles that your entire Java language is based on. Okay, so let's go one by one. Inheritance. Now, when you hear the term inheritance, what comes to your mind?
That you get it from somewhere, something else, inherited.
Right. You inherit your characters, your you inherit
Features,
property, right? So generally, or more commonly, who do you inherit from?
parents or grandparents.
Family.
Yes. From your generation, your parents, your grandparents, and all that. Excuse me, guys. Just a minute.
This conference will now be recorded. This conference will now be recorded.
All right. So you know what inheritance general term means. Okay. So let's look at how it relates to your softwares. Okay. Now this feature represents is a relationship. Is a. Okay. It allows children entities to acquire all the features from parent entities without rewriting entire existing features. In terms of OOPs or Java, a subclass acquires or can access all the data and method of parent class. This feature helps you to organize, generalize, and reuse feature. Okay. Now let's look at the example. Phone, mobile, iPhone, iPhone 4. Now, what is the feature that you generally see in a phone? I mean, a very basic landline phone.
Answer the call.
Make a call, receive call. In mobile, what are the features you find?
Call
General
and attend calls.
Downloading.
messages, right? You have messages and phone features. So does mobile has all the features that a basic phone had, plus more?
Yes.
Yes.
Yeah.
Right. How about iPhone? Does iPhone have all the features that phone and mobile had, like making call, receiving call, and messages?
Yes.
Yeah.
Does it have more features than what a typical mobile or phone has?
Yes.
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 You have camera and you have browsing features and all that. Go one more feature ahead and you get a lot more features on top of it. Okay. So in iPhone 6, if you had camera and all that, in iPhone X, you have all that plus facial recognition. Okay. So that's what the usual behavior goes. Okay. Now, is it fair enough to say iPhone 4 is a phone?
Yes.
Can I say a phone is an iPhone 4?
No.
No.
Yeah, you can't say like that. You can't go in reverse order because phone, a landline phone, can it provide you all the features that an iPhone 4 could?
No.
No.
No. But can iPhone 4 give you all the features that a basic phone had?
Yes.
Yes. So that's why you need to remember how you invoke this statement. Okay, you can never say iPhone phone is a iPhone 4. You can't say that. On the other hand, you can say iPhone 4 is a phone. Okay, if all the features in iPhone 4 is available in phone, then you could do that, but that's not the case. Okay, so remember how you spell that out. Now let's see how these things come into picture: organize, generalize, and reuse. Okay. Now, what is the problem you see here?
Camera should need to be in all three.
Okay. Aren't you repeating the code, the program for these features over and over?
Yeah,
Yeah.
they are inheriting. Yeah.
Mm-hmm.
Right? So there is a duplication. You already had one program which does make call, receive call, message. In the next launch, when you did launch the iPhone 4 model, you are rewriting all the software again with one additional feature. In iPhone 5, you rewrite everything with additional feature. So there is a sort of duplication going over and over. Okay, it will cost you in terms of time and money. Okay, so in inheritance, what we do is we do something like this. So when you say extend iPhone 3, all the features that you have here in this program will be inherited by iPhone 4. So right now in iPhone 4, how many features do you have? One.
iPhone 3 and then adding like browse.
Do you have one feature or four?
Four.
Features.
You have four features. Three features you inherit from this program, and one you have here. How many features does this program has?
5.
5.
It has 5. Okay, so you inherit one feature from your parent and 3 features from your grandparent. Remember, it's a hereditary chain here. Okay, it's the same vertical line. They all belong to the same family. So whatever you inherit here in iPhone 4, it is available here as well. So iPhone 5 has 5 features, 3 from the grandparent and 1 from the parent, 4, plus 1 new feature right here. Altogether, you get 5 features here. Okay. Now, that's what the term reusability and organize means. Okay. So I'll get to generalize in a minute. Now, at any given time, okay, let's see what is the other feature. One thing you already know, reusability, right? Reusability is one clearly beneficial thing here. Now let's see another use here. At any given time, people have different iPhone models in the market, isn't it? I have iPhone 8. There is one person who owns iPhone X. There are few people who are still using iPhone 3. So all the customers of Apple products, don't they have variety of iPhone models at any given time? Or does everyone own an iPhone X here?
Variety.
Okay. Now let's say the Apple iPhone had a bug, had a problem in the way you make a call. Okay, so there is some error, some problem in the way you make a call. If you dial 911, maybe there will be some error and your iPhone will crash. Okay, so you have to make a code, you have to make some fixes, you have to provide some solution to that problem. Okay, now without inheritance, how many places would you have to make a change?
In one.
One place.
Without inheritance. In all the models, isn't it?
Yeah.
Without inheritance, you have to make a change in the make call feature for iPhone 3, then make call for iPhone 4, and finally for iPhone 5. You have to make changes in several places. Everywhere you see this make call. Now, if I make a change in this place, don't you inherit all the things that you get down the line?
Yeah.
Mm-hmm.
So you
Yes.
inherited everything. Whatever problem you had, you fix in one place, and that will be inherited by program 4, program 5, and everything. So this gives you that flexibility. Okay, you can make changes without impacting all the other models. You make change in one program, and every program that inherits from that in this program will inherit the change as well. So you don't inherit an existing feature, but you also inherit whatever changes are done in this program. So now you can go back in time and fix whatever problem you had. You can go back in time. Okay, now that's one more thing. Flexibility. Your program is very flexible. You make change in one place and it applies to everyone. Okay. Now let's say the Apple team decides that every iPhone should have a facial, not facial, but every Apple phone should have, let's say, which feature is not here?
Fingerprint.
Fingerprint scan. Okay, every iPhone should have a fingerprint scan. Now, without inheritance, what you have to do?
Entry.
You have to write that in all the places. Okay, now if I write it here, did iPhone 4 and 5 inherit the new feature that you added?
Yes.
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 Yes, because they are extents of iPhone 3.
The extent. So whatever you do, if you add a new feature or if you modify an existing feature, they will inherit everything. That's the beauty of it. So you can adapt to any new requirement that you get without making changes in multiple places. Add a new feature and everyone get it. Okay, this is just a sample example I'm giving how inheritance would work. Okay? But it doesn't mean that you actually will be able to do fingerprint scan on iPhone 3. Okay, because if you really want to take it literally, then you need to have a hardware that can actually scan your fingerprint.
Yeah,
Just
you have to
software
change the
alone.
structure too.
Okay, so this is just a theoretical example I'm giving to help you understand what exactly is the benefit of inheritance. Okay. All right, so generalize. Let's take the example of Nissan. Nissan model, see, every car has different plans, right? Basic model, some SE model,
XLE
XLE model. There are several models,
and
right?
premium.
Premium, okay. Now, tell me one thing. Does Nissan have different factories for each of these? Basic model, SE model, XLE, premium?
No.
No,
No.
only one.
They won't. They will have only one. Because whenever you launch one model, 95% of, even 99%, who knows, 95% of components are same. Okay, your engine is same, your make and model is same. Maybe SE has a rear view camera. Okay, XLE has a really good speaker, and premium model has everything: rear view camera, good speaker,
Luxury.
okay, and maybe some fancy, moon roof, something like that.
More seat maybe.
Okay, so that's how the factories also think, right? Now what they do is they have one giant Nissan factory where they create 95% of the Nissan car components. a really big factory which develops 95% component of each of these car models. And then you have a very small shop which specializes in only rear view cameras. Okay, and another small shop for only speakers and for designing moonroof.
Moonroof.
Okay, now that's how it is. Okay, another small shop for just the body. Okay, outer body. Now, what do we call this factory as?
Nissan.
Main factory.
Generalization. Generalization is the one thing which is common in everything. 95% of the Nissan car components are common. Okay, the make and model changes, the body style changes. Okay, maybe you have a sleek rear view. Okay, maybe you have a different camera, different speaker, but the engines, the motors, okay, the core 95% component are same. That's what the generalization means. Okay, but here is the thing. Is this a complete Nissan model? Can you sell a car which is only 95% complete?
No.
No.
It has to be 100%. Maybe you have to complete that with a specific camera setting or specific make and the body style. This is not a 100% car. Okay, this is only 95% car. You cannot sell something which is 95%. Okay, so the same rule applies in programming style as well. What you can do is take this example. When you go to checkout on a website, now 50% of the details are still same. Okay, calculating order, personal information, shipping information. Okay, and then you have payment. Now, except the payment, aren't these things common in all mode of payment? Now, first of all, how many kind of payments are there on the website? Credit card payment,
Credit,
Yeah.
debit.
PayPal,
Bank account, PayPal.
Bitcoin, credit card, debit card. Okay, so you have several different forms of payment. If you choose PayPal, you have to enter user ID password. If you choose credit card, you have to give the 16-digit number and expiration date and all that. If you choose Bitcoin, you have to give the Bitcoin wallet number. So this is the one thing which varies from person to person, from payment to payment. But tell me one thing, if you choose Bitcoin as a payment, will the website not calculate the order or collect your information or collect the shipping information?
It will collect.
It will.
It needs that. You still need the shipping information, personal information, and calculate order, no matter what is the mode of payment. Okay, so that's what the generalization comes. This is credit card payment, which extends payment. Now, this is what generalization means. Now, tell me one thing, is this a complete payment program?
No.
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 Have you seen any website that will just calculate your order, collect your personal information, shipping information, and that's it? You get your product.
No.
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 They would go bankrupt within a day or two, right? So that's the same concept that I applied in the generalization rule. 95%, no one wants to buy a car without the doors, without a body. It is just 95% complete. Similarly, this is not a truly complete payment process, but this will help you in terms of inheritance. You don't have to write this code in every program that you have on your website. You don't have to repeat that over and over. That's what generalization means. You take the most common features and you put it aside for reusability. Now you say extends, so they all will inherit these three features in credit card, PayPal, and Bitcoin. Okay? So you see the benefit of inheritance, right?
This conference will now be recorded.
Okay. So let's see the next feature, encapsulation. Encapsulation is a way of organizing data and methods. Encapsulation uses different access privileges on data and method to hide, protect, organize data and methods. This feature allows enterprise application to maintain confidential information. Okay. Now take the restaurant app. Okay. Now chef has two features. They can cook and they have some secret ingredient. Okay. Now this is one trade secret that you have that you don't want to share with anyone. Okay. These are all programs, right? Chef is a program, cashier, customer, waiter, food. These are all different programs. Now think about this thing. The reason this restaurant is so popular is because of the secret ingredient they have. Now, if this secret becomes public, would any customer come to this restaurant, or would they just cook themselves and save money? Yeah, there are few people who still go to a restaurant, but you get the idea what I'm saying, right?
Yeah.
There are some things that you'd like to protect for some personal reason, confidentiality, your privacy. Okay. Now, Java programs, the object-oriented programming language allows you a way to protect certain features for your own good. Okay, so if you know what is the secret for KFC chickens, what is the secret spice they add, right? They would be losing a lot of money. The reason they want to keep that as a trade secret is because that's the main reason people come to the restaurant. Same goes with Google. If someone else knows what is the Google's search algorithm, how they actually search all the data, that's a trade secret. The entire company is built on that one algorithm, that one logic, how you search. What is the logic? What is the algorithm? If that becomes public, any other company could come up with their own search engine and take all the business away from Google. So don't they want to protect that?
Yes.
Yeah.
Take a person. A person has information like name, age, SSN. Now, which one you don't
Driver
mind
license.
sharing with other people, and which one
SSN.
you'd like to protect?
Social security
For protect.
to
You'd like
protect.
to protect this. And maybe few people want to protect age as well,
Not really.
right? But how about name? Is there any problem sharing your name with any other?
No.
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 So encapsulation allows you to mix and match what you want to protect and what you want to make it publicly available. Okay. Now here is a healthy mix. Okay. You want few information to be publicly available and few you don't. So encapsulation is a process where you manage all the information in whichever way you see fit. Okay, whatever you want to protect, you can do that. You can make sure this program, no one can access, no other program can access the SSN of a person, but they can access the name or age. That's what encapsulation means. Okay, so the name encapsulation is derived from this term capsules. Okay, what do you mean by capsule?
Something put inside the capsule, like
Medicine. Okay, so you don't feel good, you have a fever, you eat a capsule. You really don't know what's inside the capsule, right? You don't know what chemical
Yeah.
ingredient.
Mm-hmm.
Everything is nicely wrapped outside a capsule. You just eat it and you feel healthy already. That's what encapsulation means. So your program is designed to achieve whatever you need. You want to process your payment, it will be done. But we will never reveal our trade secrets, our private confidential information. We will get the job done. Just give me your payment information, how much money you want me to pay, and I will pay it through my credit card. No one has to know what my credit card is. I'll keep it secret. But what you want is payment. I'll get that done. So encapsulation is a process where you make some features, you try to hide some features, and you make other features publicly available. Okay. And abstraction, if you realize, the definition sounds very, very similar to encapsulation. Okay, but let's look at it, what exactly it means. Abstraction allows us to hide internal complex implementation and allows the end user to use interface without being concerned about internal complexity. Okay, so let's take this thing. Even abstraction is talking about hiding things, right? Hide internal complex implementation. Encapsulation also talks about hiding private data. So this is a very popular question even in interviews, because the definition is very, very similar for encapsulation and abstraction. Okay, so let's take an example and see what exactly encapsulation and abstraction means. Now, building a car, there are two people involved. Okay, one is the automobile engineer who deals with car, who designs car, who builds car. Now, who is the other person who deals with car? The customer,
Customers.
or the driver who actually uses the car, right? So this is the designer, and this is the user of the system. Okay, car is a system, and two people work around this. There is an engineer who designs it, and there is a user, there is a customer or driver who uses the system. There are two roles. Okay, so designer is the person who decides what needs to be hidden for customers' own good. Okay. So when you guys drive a car, do you really need to know how the internal combustion works or how the fuel tank works?
No.
Which are the features which you really need to know if you want to drive a car? You need to know how to start a car. You need to know how to use the steering. You don't have to know how the internal combustion works and how the fuel tank process works. So designers usually have the internal view of the system, and users have external view of the system. Internal view of the system is encapsulation. External view of the system is abstraction. Okay, encapsulation makes sure that the user of the system is safe while using the system. Abstraction of this system, abstraction defines how can we make the system usable with minimal effort. Okay, so if you want to drive a car, do you need to know how the car works, how the internal combustion works? No. All you need to know is how to handle the stick, how to use the steering, how to use the
brake.
gas pedal. That's all you need to know. That's the abstraction. So until now, you guys have been doing the abstraction way. Okay, you guys use the cell phone every single day. Do you know how the mobile technology works?
No.
No.
But do you still know how to use a mobile?
Yes.
Yes.
Yes, that's the abstraction view of mobile. You guys use the laptop. Are you by any chance a hardware engineer? Do you know how the laptop works?
No.
No.
Do you know how to use the laptop?
Mm-hmm.
Yeah.
Yes. So that's what abstraction means. Abstraction is supposed to be the external view of the system. Encapsulation is the internal view of the system. Okay, you decide what needs to be protected and everything. And in case of abstraction, you decide what is the minimal interface I can give to the customer so they can use it with minimal knowledge of the system. They need not know how the mobile technology works. They need not know how the automobile technology works. They need to know how to start the car. They need to know how to take a turn. They need to know how to make a call. Abstraction is the outside view of the system. Encapsulation is the inside view of the system. Okay, so here, if I'm an automobile engineer, if I'm the programmer designing car, I will decide this should be publicly available to everyone. Anyone should be able to use the steering feature. Everyone should be able to use the ignition button. This one, I'll make it more of a private. Okay, encapsulation and abstraction. Abstraction defines the outside view of the system. Encapsulation defines the inside view of the system. Okay, that's the only difference. So all the while you rely on certain programming features, public, private, to control what should be accessible and what should be protected. Okay, you don't want customer to put their hand in the engines while they're driving, don't you? It is safely tucked away in the rear trunk or in the front, away from the customer's passenger, seat. And it is done for their own good, isn't it? We don't want customer, the driver, to harm themselves. So for the sake of customer's own good, we decided I will tuck the internal combustion engine far away from customers, harm. So that's how you design the software. When you design the software, you decide how can I make this system easy to use without bogging them down with the whole technical details. No one knows how the internet works, but aren't you able to post a message, post pictures, place order, transfer money. So isn't the whole internet an abstraction example?
Mm-hmm.
Okay, so that's what the difference is. Abstraction focuses more on how the customers view our system. Encapsulation is more about the internal details. How do I make the system more safe and easy to use? What should I keep it away, secure, tucked away? What should I protect? Okay, that's encapsulation and abstraction. So in short, if anybody ever asks you, what's the difference in these two? The in short answer is, this is the external view of the system and this is the internal view of the system. All right, so polymorphism. Polymorphism means, poly means many, right? Morphism is like form, many forms. Now this feature allows us to define same functionality in multiple ways based on the input provided. Okay, so you can implement, you can write the same functionality in multiple ways. Take the payment example itself. Now, aren't they all form of payment?
Yeah.
So a person can do the same thing. There is one functionality called payment on the website, and a customer can choose to make a payment in 3 different ways. They can use a cryptocurrency, they can do PayPal or credit card. That right there is a polymorphism example. Doing the same thing in different ways. Now, isn't the input different for credit card and PayPal and Bitcoin?
Yeah.
But is the end goal, is the functionality still the same, payment?
Yeah.
That's what polymorphism is. Okay. Now give me an example for polymorphism on the websites. You guys have been using internet for decades, right? Yeah, you guys are not as old as me, so maybe a couple of years. Okay, so give me an example.
Login.
Very good. What is the polymorphism in login?
Username, password.
And what are the other ways to log in? Remember, polymorphism meaning many forms. One way to log in is user ID password. Is there another way to log in?
Fingerprint, face.
Face ID.
Email ID.
Email ID, phone number.
Fingerprint. Facial
Okay,
recognition.
phone number, they'll give you a passcode, you enter that. You can log in with your finger scanned. What are the other ways to log in?
Facial recognition.
This is polymorphism. You can log into the system by entering user ID password, or maybe you can just enter the phone number and they will text you a passcode. You enter the passcode, you're in. You can just put your thumb. Okay, like most of the mobile apps, you don't have to log in. You just put your thumb, it scans, and you can access the app. Or you can do facial recognition. But aren't these different ways for the same functionality?
Yeah.
That's polymorphism. Okay. And finally, platform independence. Okay, we have already gone through this, right? So let me just go through the definition. One of the features of Java is Vora. Write once, run anywhere. Okay, so like I told you guys yesterday, you can write the program in any operating system. You can write the program in Windows or Mac or Unix, any operating system. The same program, when you run the program, when you execute, or when you launch the program, you can do that on any other platform. The same program can be executed or launched in a Mac, Windows, Unix, any operating system, any platform you want. Write once, run anywhere. That's the mantra here. Okay, platform independence. Developers need not write different code for different operating system. Okay, JVM makes the code translation to underlying machine. Java has a compiler and interpreter. Both together make it language platform independent. Okay, so compiler is the one thing which is common. Okay, now if you install JDK for Mac and JDK for Windows, JDK comes with two things. What are they?
Compiler and GR.
Compiler and
Okay, JVM or interpreter, whatever you call it. Okay, or JRE. It comes with compiler and JRE. When you do JDK Mac or JDK Windows, here the same compiler is what you get. The JRE will be different. Even here, compiler is same. Okay, both these are same. Only thing that differs from platform to platform is the JRE. Okay, this is specific to a operating system. Compiler is always same. That's why the name intermediate binary code. Intermediate binary code is same. It works everywhere the same way. JRE is the one thing which differs. Okay, just like a translator, interpreter. Okay, language interpreter. So JRE or JVM. Okay, JVM is the component of JRE. Is the one thing that makes your Java program platform independent. You take the same program, that same class file that you have. It might be created in Windows, Mac, Unix, doesn't matter. This class file, when you pass it to Windows JVM, it will convert into Windows program. You pass the same file to a Mac JVM, it will convert that into underlying operating system Mac. And same happens with Unix. That's why it becomes platform independent. JVM, the interpreter, is the one thing that makes your code platform independent. Okay. All right. So these are the foundation. These are the principles, core principles of Java programming language. Okay. This is the these are the main things that you need to build your program on: inheritance, abstraction, encapsulation, polymorphism, and platform independent. Okay, these are the features you need to remember. Whenever you write a program, always think from these specific things. Okay, these are the core features. If you're not using polymorphism, encapsulation, abstraction, any one of those, it's not really a good program. Okay, you have to think about all these things. Okay. All right, so real quick, now every object in Java program has two features. Okay, has two categories. Okay, one is the attribute or component, and the other is the behavior or activity. Okay, let me give an example and you can understand this. What you need to pay attention is these two statements. Okay, Now complete this statement. You have to choose one of these and relate these two. Now what did you
Car.
say? Car
has
does
wheel.
wheel,
Contain.
contains wheel. Very good. So now wheel is what? Attribute or behavior?
Attribute.
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 How
Does.
about drive?
Behavior.
It's an activity, isn't it? It's not
Drive.
something that you can see or do. It's an activity. Steering,
Attribute. Attribute.
Contains.
start,
Activity.
Behavior.
Act-
Activity.
Stop activity.
stop.
Activity.
Okay. So if you notice, any object that you can think of always falls into two categories. Every object in the real world has these two things, has and does. Okay. A person has hands and legs, has, right?
Yeah.
Now give me an activity.
Person walks.
Walks. So do you say person has walk or does walk?
Does walks.
Does walk.
Does
Speak.
walk.
Activity.
So that's what you need to remember. Okay. Everything, anything you can think of, they always fall in these two categories. A bank account, okay, now tell me which are attributes and which are activities.
Withdraw is
Account,
activity.
account number is attribute. Withdraw activity. Money.
One is attribute.
Money is attribute.
All right. So now let's get more technical. Every program, every Java program has two parts, variables and methods. Okay. Whatever you said attributes, the more technical Java word for that is variables.
Variable.
Okay, variable or data, whatever you call it. Okay, the one we call activity is called as methods. Okay, so every Java program has two parts, data and method. Data is a more layman term for that, is an attribute of the system or a component of the system. If you want to know how to write that in a program, always ask this question. Take two words and try to associate them with a has a or a does a connection. Okay. List everything you can think about chef. Okay, list everything that comes to your mind about the chef. And then try to figure out which are variables and which are activities or methods. So which is attribute and which is activity?
Name is a variable.
Name is attribute.
Name is.
Cook is
Salary is a variable.
Other is variable.
And cook is a method.
Cook is method.
There you go. Okay, every Java program looks like this. Every Java program looks like this. They have variables and they have methods. Okay. Now, remember the connection between these two. Okay, they should always be related to each other. Data and method, they go hand in hand. Okay, that's one of the thing about encapsulation. Data and method, it goes hand in hand. Take the person example. Now, which are variables and which are methods?
Hands variable.
Method is walk, eat,
Walk, eat.
and
Correct.
leg, mouth is attribute.
Okay, that is right. Now, here is the question. If you want to walk, what do you need?
Leg.
Legs.
So if you have to write the code for this, what do you rely on?
Activity.
Rely on leg.
Use leg. How about eat method? How do you write the software, the code
Rely on
for
mouth.
eat method?
Rely on mouth.
Mouth.
Function of mouth, yeah. Hand and mouth.
You see? Always remember, every program falls into two categories. Okay, everything. For a minute, forget about programs. Just think. Okay? If you have a car, car is made of. Car has wheels. Car has steering. Car has an ignition button. Now, if I want to implement start, what all things falls into motion?
All of these, the one you said.
You need the steering, you need the gearbox, you need the gas pedal, and the
The
wheels.
key.
They all work together
Exactly.
to achieve this, to accomplish this task called start, isn't it?
Yeah.
That's how your program is also written. Writing program is not a big deal. The reason Java feels so easy is because you can relate that. Okay, everything you can actually relate that to the real world, and that's how you need. See, you should never lose your real world conception. Okay, don't try to alienate yourself from the real world. You have to always stay in the same zone. Okay, don't think as programming as a whole different world. You have to always relate yourself to the real world. That's how everything makes sense. Of course, to write a program, you have to write a lot of Java technical words, yes, but you should always stay in that zone. Okay, which makes it more relatable. Okay. Now, help me write a software for bank account. First thing you need to do is list everything that comes to your mind related to bank.
Account.
Don't think about attribute or activity. Just spell out whatever comes to your mind.
Bank teller, deposit, withdraw, account,
Routing.
types of account, saving account, checking account.
Remember, I'm teaching you how to write a program.
ATM.
Never ever say the pronouns. I need more generic term. If you say checking or saving, is that an object or is that a class?
Object,
And what is account type?
class, it's generic.
Yes. Always say to the point. If you say bank account has Chase, would that be right?
No.
No,
No.
it's object, so you need to go for class.
Bank name makes sense. Anytime you write a program, you have to be more generic. Never say Chase, 1, 2, 3, 4, saving. Never say that. They are objects. What you need to focus on is the generic types. Okay, general. Right, you
Bank,
forgot the very main important thing here. What does the bank one thing bank account has?
Routing number.
Money.
Money,
ATM.
right? Don't you need money? The whole point of bank is money.
Yeah.
All right, so see, I
Security.
want you guys to do this as an assignment. Take anything. Bank account is just an example. Take school. Take Amazon website, Facebook, restaurant.
McDonald's,
Take
yeah.
any example you want. What I want you to do is list all the things that comes to your mind. Remember, not the pronouns. I want the generic terms. What do you do? What does it has? Okay, make a list of all the has and does things. Bank has a name, bank has a number, bank account has a type, bank account has money, bank account does deposit, bank account does withdraw. Make a list of all the has and does. Okay, any example that you think of, make a list of has and does. The next thing is show me how will you write the code for this logic. Okay, this method, what you see, method is where you write your software logic. Your program is actually written inside method. Okay, now here what do you rely on if you want to write the logic for method deposit?
We need account to deposit,
Money.
money to deposit,
Money.
check to deposit.
Okay, here is the thing, if there is $100 in your money variable, $100, and if I say deposit 50, will your bank name change if you deposit 50?
No.
No.
Will your account number change?
No.
No.
Will your account type change?
No.
Maybe
No.
saving or checking.
This is the only thing that changes. So you have to make that clear here. In the withdraw, what did you want to do now?
Your money.
Does anything else changes?
No.
No.
Okay, just a dummy example. Let's say I have some activity where I can convert my account to savings. What will change here?
Account type.
Yes. Will your money change?
No.
No.
Will your bank name change?
No.
No.
No. So this is what I want you to do. Okay. Forget about the programs. Okay. Just on a piece of paper, on a notepad, on a text file, do this simple exercise. Pick up any example. Okay. Whatever software you want to write, pick an example. Okay. Then make a list of has A and does A. Make a list of all the things. Okay. So for example, if I want to do software for online shopping, okay, online shopping has,
A
complete the
website.
sentence.
Has website, product.
Okay. Online shopping does.
Shipping. No. Yeah, shipping.
Let's go in a routine fashion. You log in. What do you do after login?
Cart. Select cart. Or
Do you
browse.
select cart or do you even browse?
Browse first.
Browse.
After browse,
Select.
Select.
do you select cart or what do you do?
Select product.
A select then card.
Select add in cart.
Yeah. And what else?
Then check out.
Check out.
Pay.
And payment.
So this is your program for online shopping. Has, does. Now to log in, which one do you rely on? Products or customer?
Customer.
Customer. For browsing, what do you rely on?
Product.
Add to cart,
Product.
Product.
checkout.
Product.
Checkout will require both, right? Yeah, checkout also product. Yes. How about payment?
Now customer
Customer
needed for
and
payment.
products.
You will need both.
Both.
You need what are the
Both.
products they have in the cart, and you need the customer detail as well.
Customer.
The credit card, shipping address, everything. So that's what you need to do. Okay. Simple. After you do this exercise, I want you to write in this fashion. Online shopping, variable product, variable customer, method login, in bracket write uses customer variable, method browse uses product variable, all I need is this simple plain English, not a program or anything. Come up with at least 10 examples. Okay, at least 10 examples. Simple trick, pick any random example you want, make a list of has and does. Whatever you see as has, write down variable product, variable customer. Whatever you see as does, method login, method browse, method add to cart. Now you have to think, if I need login, which one of these information do I need? If I need browse, which one of these I need? Add to cart, which one of these? This, if you're able to do this, you can write any program. So remember, the one thing that people struggle in the beginning is to understand where to begin, how to write a program. That's where people struggle. How to write a program? Where do I begin? If I want to write a software for a restaurant, where do I begin? How do I come up with a program? What do I write here? What do I write here? How do I write the code for login? That's where people struggle. Okay, so simple trick. Do this. It might sound lame, but this is a very important thing that you will ever have to learn here. Okay, once you figure out this, I can tell you how to write an actual program out of this thing. That we'll do in the tomorrow's class. Okay, I'll tell you how to write this technically in a program like this. That's what we'll learn tomorrow. But before we jump into technical language writing programs, you have to do this thing. Okay, has, does, attributes, activities. Okay, is that clear? Okay, forget about program or anything, inheritance or anything. This is a simple thing. It's a simple grammatical question I'm asking. Apply has and does and make a list. That's all. Okay, there is nothing technical in this.
Okay.
All right, and just go through some examples. Okay, I want you to apply these logics. Okay, inheritance. I gave you an example of phone, right? Come up with an example for inheritance. Okay, something relatable to the software world. Okay, like we have mobile example here. Come up with something else. Inheritance. A fan. You have a ceiling fan, a table fan. Most of the features are same, except some minor details. Okay, a TV. An old television versus plasma versus smart TV. Everything has some additional features. In the basic television, you just had cable, which directly came into your home. Nowadays, you can browse, you can install apps, Netflix, this, that. Smart TV is an inheritance from a basic TV. Apply that. Inheritance. Encapsulation. Come up with an example like person. I told you, right? Person has age, name, SSN. Which one you want to protect, which one you don't. Abstraction. A cell phone is an abstraction example. You don't need to be a mobile engineer. You don't need to know mobile technologies to operate a cell phone. Polymorphism. I gave you the example of payment and login. Check on the website. What other things you can think about as a polymorphism? For example, on Facebook, what did you say? What did you say as a polymorphism feature? Other than login in Facebook. If you have a feature called post, can you post a text message? Is anyone a Facebook user here?
Yes.
Yeah.
Can you
Yeah.
post a video,
Yes.
Yes.
Yeah.
a photo,
Yeah.
Yes.
an audio?
Yeah.
Yeah.
Aren't they all form of posting something?
Of course.
Polymorphism. So here is the thing, guys. Now you're not the end users. Now you're not the customers. Okay, you are on the other side of the internet. You're not the user of the internet. You are the provider. You're going to provide solutions, softwares on the internet. Start thinking from that point of view. Don't limit yourself from the customer perspective. You have to start thinking from the other side. Okay, look at Facebook and just guess, just wonder what would be inheritance in the Facebook website. Just look at the resemblance. What would be abstraction? What would be encapsulation? Go to Amazon, just wonder what exactly they might have applied from this object-oriented concept. Where did they apply polymorphism? Feedback, reviews, browsing, okay, product categories, post, sending text, everything you guys have been doing on the internet. Think from the technical point of view. Think from the other side, not as a customer. For the next few days, always think from a technical perspective. Think as a provider, think as a solution provider. Okay, anything you think about, look at your fan and wonder what would be the software I can design on fan. What would be inheritance? You have to make that as a habit, because believe me, it's not easy to cross this line. Okay, going from the one side of the internet to the other, from customer to a solution provider, from a technical person to a layman person. It's not easy to transition into IT world. You can only do that if you are constantly thinking about these things. Okay, if you can't constantly think about everything around you as a IT, as a technical person, only then you will feel comfortable. So the sooner you guys start doing that, the better. Okay, you have to transition from this side to the other side. It won't be easy. You can do that provided you follow these simple tricks. Okay.